Okay. Today we are going to start our actual course after giving the introduction in the first lecture, and we are starting with the simple C programs thing. Basically, I told you yesterday where we are starting with C and Java, right? So, can anyone kind of remind us why we are taking C? It's a very old language. We have so many other fancy things right now. Why C? Yeah. Good. And what is the benefit of that? Thank you. What is the benefit of like studying a language that is low level and closer to the hardware, in case that you don't care about the hardware? Yeah. Exactly. So you get a deep understanding of what is actually going on when you execute a program. Even if later you don't care about the hardware, the knowledge itself is useful, because even if you write something in a very high level language like Python or like MATLAB or Perl, you understand what's going on. So if a problem happens, you can actually debug this to the lower level. Good. C language is procedural. As we will see in the Java, it's actually object-oriented. So C actually lacks OOB. And C is a combined language. What do we mean by this? We have some languages that are actually not compilable. So to get the executable, you don't need to combine those, right? You have the source code, and then you can actually execute the source code directly. Can anyone tell us like what is the name of this thing? Like we have a combined language. What is the other type? Yeah, interpreted language. That's true. Can anyone give us an example of what is an interpreted language? Yeah, Python is an example. Perl is an example. Shell script is an example. MATLAB. Did you guys use MATLAB or not yet? MATLAB is an example which is very common in engineering, right? So in interpreted languages, you don't go through a compilation step. And we will understand today what we actually mean by compiler in some details. But C basically is a combined language. You have to go through a compiler to get the executable. You cannot just run the source code through an interpreter and then it will execute. This will not happen. So we have two separate entities. We have the source code, then we have actually multiple things in between, as we will see, and then we have the executable itself. Good? As I said, it's a very old language, like back in 70s. It's actually a very powerful language. I don't know if you know this or not, but most existing operating systems right now are based somehow on C. Linux itself, like the Unix shell, is on C. Windows early versions, and then now they have some C code. Honestly, I don't know about iOS, so if someone knows, you can tell us. But if you want to write something that is very powerful, very professional, you go to C. Can anyone imagine why this is the case, given that it's an old language, maybe it's not very well optimized, it's not object-oriented? So why C for operating systems? Yeah? This is based on the previous answer. Yeah, thank you. But there is another thing. So you want to be closer to the hardware because the operating system is dealing, as we said yesterday, it's kind of an intermediate layer between the high-level programs and the hardware. But there is another thing. C is actually very fast. Like the running time of Python and Perl and these shell scripts, because it's an interpreted language, the running time is not good. For C, it's a very fast language because you have a fine-grained control on actually what happens on the memory, what happens in the processor. So you can get very fast programs, and this is why actually another example for using C is in embedded systems or driverless cars or anything that is related to timing constraints. You want something that to act fast, then you're going to go to C, right? Good. Okay, this is something related to standards. Some of you asked me yesterday about this. We have multiple standards of C. The most up-to-date one is C11, but we don't really care, right? So what we are going to, this is an introductory course. So what we are going to write in this course, in the labs, in the exam, like in the lecture quizzes, it doesn't really matter which compiler you are using. We'll try to stick to the oldest one, which is 89, to make sure that it combines across whatever compiler you have. But as I said, you shouldn't care much about this. Right? Any question? Right? For the C standard library, we will see what we mean by library right now. But basically, in any programming language, if you have a library support, that means these are basically a set of programs that are pre-written, and you can utilize them as functions, right? I guess you did this, guys, in Python the first year. You don't write everything in just one file, right? If you can write your helper functions, you want, for example, to display something on the screen that is complicated, so you write a separate function for that, or a module, or whatever you call in the language, right? In C, you can also do the same thing. It's function-based language. But also you have what we call the language library itself, which is a set of functions, simply a set of functions that you can utilize, as we will see today, to help you write your own programs. Good? But this is nothing other than just C programs that someone already written, embedded into the language such that you can use. Right? Good. So now we're going to see, to introduce ourselves into how to write something in C, very simple, like a low program program, and then compare this with Python, given that this is the language that you guys know, right? So here, if I want to print something in Python, I just define my main function, right? And then write print something. This is going to display in the screen, right? In C, you do something that is very similar, but it's more strict. First of all, you define again like your main function. You have to have this in C. There is no program in C that doesn't have a main function, because this is the starting point when you execute your program, right? So you have the executable. What tells the hardware to start executing which instruction, right? This is the main function. This is the starting point of the hardware to execute your program. So you have to have a main function. And then, as you can imagine now, printf, this function, is basically achieving the purpose of printing something on the screen. And then the return 0 thing, we will come into this like in details now, but basically you define a function. So this function has some return value, and this is why at the end you return 0. Int is an integer, so you have to return 0. 0 means you have no error, right? Later, if you write complex programs and then you write an error handler or fault handler, you will return something else. So 0 by default, this is by default like the last line of any main function in C. The reason for this is if you return 0, that means you pass through all the program, you reach to this stage, so you return 0, which tells you that you have no errors in your program, given that you already proceeded and executed everything until this line. Any question? Good? Okay. Basically explaining the main function, let's go back here, forget about this thing. The main function is nothing other than a function in C. So the way you define functions in C is exactly the same thing as the main here. This is the function name. For main, it has to be main, yeah. Yeah, so as I said yesterday, actually we got the Avenue to Learn web page working. So I'm going to upload yesterday's and today's slides. All the slides will be on the Avenue. So don't worry about writing, like everything will be there. So this is the function name. Good. For main, it has to be main, and it has to be low case. C is case sensitive, so it has to be main as main. Everything is lowercase. And then int, as I said, is the return value, which means when you go to execute this function, you do something, and then you have to return the result, right? So this is the return value of any function in C. And then what is between these brackets or parentheses is basically the inputs to this function. Good? Because in functions you can take inputs. If you are summing two variables, for example, you are writing a function that is called sum two variables. It takes x and y, right, and returns z. So you take x and y as an input, which you put here. We'll see this later. You add them, and then you return z at the end, which is the return value. So these are the inputs. This is the output. This is the standard for the main. But what I'm explaining to you right now is the general template of writing a function in C, because it's exactly the same thing. Any question? Yes, this is very basic, right? Good. Void here, the thing that I didn't say is void here means the main takes no argument, because this is your start point, so you don't pass anything to this function, right? So it's void means I just take no inputs, I start from here. we will go to this line, which is printing something in the screen. So this is very similar to this one. So the syntax is very clear. The only thing that you need to know here is, for Python by default, it actually prints in a separate line each time, right? So it, as if it was a line breaker for each print statement you put in the code. For C, it's not the case. And this is one thing that you will get the more you go deeply in C. Everything you want to do, you will do yourself. Right? The function do minimal thing for yourself because, again, you have a fine control on what happens in the code, right? So if you want a line breaker, you have to put /n. Are you guys familiar with ridge expressions, right? So /n means new line, right? These are standard things, not just for C. It's also used in Python, like Perl, and it's called ridge expressions, and it's very famous. I guess you should, if you don't know this, I guess you should know it. Right? So /n means new line here. Good. But why do we have this line here? Any idea? Yeah? And why it just don't work with printf it is? Yeah, exactly. So I didn't define this. Seems to be a function, right? Because it takes something as an input in parentheses, right? So I didn't define this in my C code, right? So there is nothing here that I define printf, right? So let's actually try something to see what will happen. So this is an online, I don't know if you guys see this. It's very weird to me. Is that clear? Can I get the white screen thing? Okay, so let's, do you guys see, or like it's very hard to read? Maybe I'll just make it bigger. Okay. So this is an online C compiler that, in case that your compiler doesn't work on your laptop and you have a quiz, you can just go ahead online, look for it, and then compile your code to make sure it works, right? But we will use this to experiment with different things in the lecture. So here we have printf, and we include the thing that I didn't explain until now, right? Let's just comment this out. Okay. So 2 slashes means you just put a comment, which means this line will not be executed, right? So if I try to execute this now, good, it works. It shouldn't be working. What if I do this? Okay. That's good. Seems not to get updated here. Okay, so I go to my own machine thing. So one good thing about programming is sometimes you will just hit your head in the laptop. Right? So you don't know what's going on. C compiler is stupid, but this is not because of C compiler, this is because of like the website is not working well. But basically you will see these things in the lab. So here this is a program, I guess this is much better. So I don't even see this. I don't know if you see. But basically we are printing 2 statements here, and then again we are including the studio.h that I didn't explain yet. So let's comment this out. And then I'm going to compile this. Oh, it doesn't compile, right? And the reason is it says, I don't know if you can read, but it says implicit declaration of function printf, which means you are using a function that you didn't actually define, right? And then it gives you a suggestion, which is like a generosity of the compiler itself, which usually doesn't do that. It tells you you should include studio.h to provide a declaration for printf, right? Because this is a very obvious error, which means this is a function. If you go back here, printf is basically just a function similar to main that takes some input and then it does something. But you didn't define that. And as I told you at the beginning, you have some helper files from the C language itself. One of them is the studio.h, which, as your colleague said, it defines the I/O functions that deals with the screen and then keyboard and these kind of things, right? So studio.h is actually a header file. .h is a header file that has the definition of the printf function. So in the C language itself, there is some file that's called studio.h that defines what is printf, and then we also have studio.c, which tells you what the printf should do, right? Which is doing something on the screen. Good? Any questions so far? Good. So the way we include other files in the source code, if you are writing a program, you use this declaration of include thing. So here we included this file, which means at the end for the compiler, your program is not just your file. It's actually going to copy this studio.h at the beginning of your source code. So your source code will include the studio.h and then your source code itself, right? So include as if you are taking copy and paste, but in a more modular way. Good? So now, I already printed something on the screen, but what if I want to read something from the screen? Again, it's part of the studio.h thing. In Python, you use the input function, which tells the program to read something from, it's going to print this message and read something from the screen and then put in the num variable, right? In C, we do something that is very similar. You define, here you didn't define num, right? This is the easy thing of Python. This is why it's one of the most famous languages, because it's very easy. You use a variable, then it's defined by default. C is a strict language, which means if you want to use a variable, you have to define it first. So if you didn't define any num, and then you use it later, you will have a compiler error, which tells you num is a used variable that you didn't define, right? You have to define. So we define num as an integer, and then we use printf, enter an integer, because we want to print a message on the screen before reading something. And then we use another function from studio.h, which is scanf. As you can see here, this line now is 2 lines in C, and it separates the output and the input. So you output something on the screen, and then you take it as an input. Scanf seems to be complicated, but it's actually very easy to read. Again, it's just a function. These are 2 inputs. The first one basically tells the program what is the type of the variable that you are reading from the screen, right? So as a program, I'm expecting a variable from the screen, but should I read the whole line? Should I read 1 digit, 2 digits, 32 bits, 64 bits? Right? You should tell the program what to read. Good? In C, we use this kind of declaration to tell the program that you're expecting here is a float or double thing, which is like a decimal value, right? So, and then you put the value you read in this variable, which is num, right? What is this and thing? Something good about C again is you have very detailed, fine-grained control over what's going on. If you read a variable, this variable is going to be placed in memory, right? The variable doesn't only have the value, but actually it has an address as well, right? Usually, if you want to read only the value, you use this AND thing, right? So basically, just one statement, this function is saying read a float or double, basically decimal value from the screen, put the value itself in the num variable. Is that clear? Any question? And then now you print something which is the square. Yeah, this is the second line here. So basically print the square of the line of the input that you just read. So you read the square. You print the square of the number you read. But now printf turns out to be more complex as well, right? Here it was very simple because you were only printing strings. Printf is very powerful because you can also print strings and a combination of decimal and integer and stuff, right? How to do this? Again, through these kind of declarations. What will happen in this printf is you put a new line, and then the square of something that we don't know yet is something, right? What are these? These are two inputs that will be placed. These are as if they are placeholders, right? So these are holes that will be filled on the string. What will fill them? The order of these other inputs. So the first input will go to the first placeholder, the second input will go to the second placeholder. So the square of whatever, here is num, is another double or float thing, which is the num multiplied by num. Good? Is it getting complex? Yeah. Not integers only, it can be double or float, so it can be decimal floating point things. But I guess it only places them in decimal. There are other things that will be in hex or binary. So the complete list of these things we will touch later, and if you look them up, you will find them. You don't need to memorize them. Basically, when I write a code, I look up if I want to print something in hexadecimal or like in binary or in 10 digits, because also you can actually define you want to print it in how many decimal points, like up to 3 digits, up to 4 digits, up to 10 digits, right? So these things can be defined as well. Yeah. Does this answer your question? For f, yes. So the difference between, that's true. So the difference between float and G double here in C is actually just the size of the variable itself. So the float is just 32 bits, the double is 64 bits, right? So it's, but again, the same type of variable. But to be accurate, you are correct, right? Any other question? So as I said, you have to define your variable, and then all declarations have to be before using this variable itself. And we will come to defining variables in the next lecture, so don't worry about that. We already explained the scanf, and these are the specifiers for f. Oh, this doesn't have to be int only. That's interesting. Let me recall. So it's something that we can actually try. What I recall is actually for D, you can also define a decimal value thing by putting the number of decimal points you would like, but maybe I'm mistaken. So C is for character. Character is just 1 byte variable, so it's just C, F, A, this kind of thing. And then we will come into variables next lecture, but basically in C, we have so many variable types, and the reason for this is you can define what is the width or the accuracy of the variable you define. What I mean by this is you can have a number that is 32-bit. It's again an integer, right? But also you can have a number that is 64-bit, but again it's an integer, but it uses the double precision registers, right? So the width of the variable bits, the number of bits, in addition to the variable type, whether it's integer or float, and what I mean by float or double is it's not an integer value, it has a decimal point value, right? So these things these combinations gives us a lot of C types that we will see in next lecture, right? But what we are focusing on here is how to get some of the types in the printf or scanf, right? So this tells you the placeholder you are leaving in the string here is going to be so and so. It's going to be integer or string or character, right? Because what if the type here doesn't match this type? Can you imagine what may happen? For example, here this states it has to be integer, but then I I put here like a character variable. What will happen? Or it has to be integer, but I put like a floating point number or like this value. What is that? Screen? Sorry, I don't hear. How many characters in the string? Find a string? Because C doesn't have the string thing. Now we don't define that. You don't use it as these double quotes, right? But forget about defining. I'll come into this later for sure, right? But let's focus in our question right now. What if I put a variable type that is different than the one that I'm expecting? This can be a sample question that you can try on laptop and see what will happen. Yeah. Error. In some cases that will be true, and this is like the expected answer, so thank you for that. Basically, you will get an error if C cannot convert the input into the type that it's expecting. What I mean by that? So basically, if you are expecting an integer and then you have a floating point number, you can actually cast this into the integer by just truncating the decimal point, right? If it's an integer, so it's actually the other way around. It's easier. It's just translate or convert an integer into a floating point number. If you have 1, you can have 1.0. It's the same thing, right? So you can, what we call in C, casting, and we'll see this later. So if C compiler can cast the input to the expected value, it will work. It will not complain. But if it cannot, something, for example, if you are expecting a character, but you give a number, something of that sort, if it cannot cast it, then it will just complain. Good? So you'll get an error if the compiler cannot handle it. Good? Yeah. Can you just raise your voice? What is the point of this scanf function? To get the input itself, right? So printf only outputs something on the screen. Scanf is the other version, which is reading something from the screen. In Python, I understand this question because you are coming from the Python background, which is basically, or something you can say is scanf is similar to the input here, right? The only problem here is input actually places something on the screen and reads it at the same time, but C cannot do this. C has to print something first through printf and read from the screen by scanf. Good? Good. Okay, so now we go more deeply into understanding how the compiler process works in C, and this is very important to understand the types of errors you get and what happens behind the scenes, right? So basically, these steps are the steps where you, starting from writing your own program until you place this in the memory, right? So what you usually do is basically open an editor, whatever the editor is, right? Whether this is your compiler, text editor, and then you write your program, and then you save it. When you save it, you actually save it on the disk, right? And then later, if you start compiling your program using a compiler, it will do the first step, which we call preprocessor. Preprocessor simply preprocess your code, which looks into the code, try to scan it. If you have any includes, it will take the includes, put it in the file itself. So it gives you another C program. So let's actually go to this. This is simpler. So you start from a C code. You preprocess this. It gives you another C code. We will explain this now. These two are different. And then this C code will go to the compiler. Now it reads a high-level C code and it gives you an assembly code. Do you guys know what is assembly? Yeah? Assembly is the lower language that the processor understands. So one example of an assembly is, if you take a digital design course or maybe microprocessor course, you will see this. It's not working as usual. It's not working as well. That's good. Okay, so let me do this. I actually have an example here, I guess. Good. So this is an example of an assembly code. It's the lower level code that the processor understands. For example, here you have an AND function. What does it AND do? Basically takes, you know what is AND gate, right? So you take two inputs and you AND them. Do you know this? Do you know logic design, right? So this is the AND thing. Move is actually moving something from a variable to a variable. Like if you do x equals z in C code, it will be a move instruction. These are the instructions of the processor, right? If you are writing a microcontroller code, it can be in assembly as well. For example, sub is just a subtraction. So if you have a C code that is z equal y minus x, it will go to as a sub instruction in the machine code. So subtract a register from a register and then put this in another register, right? You will cover this in microprocessor course, but basically the assembly code is the lower level than the high level code. So you start from high level, you compile, go to assembly, and then later you assemble, go to the machine code. What is the machine code? We all know that actually these machines are dumb, right? They don't understand. Right? Is that true? Yeah? They only get zeros and ones. The way they work is through reading zeros and ones, right? You have high voltage, low voltage. I guess you all know this, good? So everything you write, whatever complex algorithm you write, at the end it has to be translated into a stream of bits, ones and zeros, right? So this is the machine code. So you start from the high level C code, go to the assembly, which is a lower level, and then you assemble and go to the machine code. Good? So yeah, so this is the compiler gives you the assembly code, and then the assembler gives you the object code, which is the binary code, and then later a linker takes multiple object codes, as we will see, and give you the executable. Right? So you have a long process between the C code and the executable that you actually get to execute. This is the one that you run to get the result, right? And then at the end, if you, like the way you run your executable, for example, if you double click this to run it, what will happen is we have what is called the loader. It takes your code, put it in the memory to enable the processor to start executing it. So the loader only works when you start executing your executable. Good? This is very important to understand. So if you, and we'll go into some details here, but if you have any question, let me know, right? So for the preprocessor, we said this is an example of a program that we started from. You just print something, and to print, we said you need the include studio.h, another header file in the C library. For the preprocessor, it basically will take this include directive and replace it with the actual code of the studio.h. So what the preprocessor does, as if it cleans your code. So it looks for any definitions you define, place them with the actual value, looks for any includes you bought, place them with the actual code. So the result, the output here from the preprocessor will be your program, but any other thing that is in studio.h will be actually be here in the top. Is that clear? So you can expect to find the definition of the printf here. The compiler, it takes the clean preprocessed C code, and it gives you the assembly code as we explained earlier. Good? And then the assembly code will go into the assembler, which gives you the binary code, or what we call an object code. These bits are the bits that the processor understands, right? Zeros and ones. Good? And then finally, we will start by writing very simple C programs. So you usually have one source code file. But what happens in big programs or like in big projects is you have multiple source codes, you have multiple header files. So you have a big project, right, that has multiple things. At the end, you want one executable, right? These things are related. So it's the function of the linker to link everything together from multiple object codes, in addition to adding any libraries that are needed. For example, for studio.h, you need the studio.c value, or you need libc, what we call the C library, to use the printf, right? So any library code, in addition to any object code you have in your project, will be linked together to give you only one executable. Is that good? Yeah? Good. And then finally, as I said, the loader will read your file from the disk, executable. Once you execute your code, it will go from the disk to the memory, and the processor will start reading from the memory, executing line by line, adding something, subtracting something, etc., etc. This is basically what I call the journey of a program from writing it into executing it in the processor, right? Again, this is a difference between an engineer who knows what is going on behind the scene and someone that just programs, right? A program takes the result. So it's important to understand this. Any question? None? Something I can do now, I don't know if you will be able to see that, but basically I want to show you the intermediate files because in compiler, at least in Linux, you can see the intermediate generated files, right? You don't only see the executable. I can actually tell the compiler to show me the preprocessed file and the assembly code, right? So let's try to see this now. So this is our, okay, I don't know what happened, but let's see. Can I get this bigger? So this is the program. Sorry in the back if you cannot see. I'll try to learn how to make the screen bigger in Linux. But basically this is a simple C program that you bring 2 lines, principles of programming, and comp eng to sh4, right? And then you return 0. This is the program that we were looking at in this lecture. What I want to do right now is to compile it, but tell the compiler to show me the intermediate files, like the ones that we just discussed, right? So what I'm going to do is just do this. Oh, I already commented this out. Okay, so now we should have the intermediate files. The example.i is basically the preprocessor. So let's look into here. So this is the preprocessed file. If you look here for main, you can see your code at the end, right? This is our code that we just written, which is the main, and then printf something, and then return 0. What is all of this? Any answer? Yeah? This is the preprocessor output. This is the code that we have just written. Where all of this came from? Yeah? Yeah, this is the standard IO.h that we included, right? I told you that the preprocessor will take any declaration or include you have and then replace this with the actual code, right? So this is the actual code of studio.h and studio.c, right? And then we said after preprocessor, you're going to compiler to get the assembly, which is example.s, right? This is the assembly code. So if you can read the assembly code here, basically you will find a call for, it does some kind of moving something, but then it calls printf somewhere. So this is the assembly code. These instructions are bare processor. So the compiler knows that I have an Intel machine, so it generates the ISA of the Intel, which has a move L, which means a move lower register, and then call to call something which is a printf, and then pop something from the stack. Basically, this is the assembly code. I don't want to go into details on this. You will get in your microprocessor course. And then finally, you have what is the object output, right? This object output is the machine code itself. If I open it, you'll not be able to read it. But basically, here we have only one object output. If you have multiples of these, the linker will be the one that actually adds them all and give you the executable output, right? And finally, this thing is the executable in Linux. Do you have any question? Good. So we are done for today. And again, next time, please make sure. One sec. So, two things. Please make sure you bring your laptop with you next lecture, because we are going to have quizzes from next week. The second thing is, I'm going to upload all the slides on Avenue to Learn from today, because I guess I'll receive this question a lot. So expect you should already got like an invitation, or if not, if you log into Avenue, you will find the course, right? Because I see all the list in Avenue to Learn, and I'm going to upload all the slides there. There is no tutorial. The third thing is there is no tutorial this week, so we'll start tutorials from next week, because I said tutorials will be the week before the lab, and the lab exercises will be also posted next week. Thank you. If you have questions, come on. What complex do you have?
My 4DM course, this tutorial, my lecture.
Okay. And are you blend in the lecture or the tutorial?
Well, depending on whether I would need help with like the lab exercise or
Oh, so the conflict is with our,
yes.
but with their lecture. Okay,
Yeah.
so I'm fine with that. I was thinking that our lecture is